All right, so for this one, we have special parallelograms. These are special quadrilaterals. Sorry, these are not going to be parallelograms. So all the things we've learned about parallelograms are no longer true. These are going to be shapes that have their own theorems with them. So we're going to talk about trapezoids and kites. I'm first going to go over a trapezoid. We're going to define it, learn about it, practice it, and then we'll do the kites. So what is a trapezoid? A trapezoid, it's still a quadrilateral, but it has bases and legs. Now in a trapezoid, your bases are going to be parallel. Okay, bases are parallel. And then your legs are what are connecting the bases. Here's a leg, here's the other leg, here's a base, here's a base. Okay, so that's a basic trapezoid. Now what we're really going to be talking about are isosceles trapezoids. Now let's go back to triangles. What does isosceles mean? Isosceles means we have two congruent sides. Same thing here. For an isosceles trapezoid, the legs are congruent or equal. So if I draw out my lovely isosceles trapezoid, I have my bases are parallel and my legs are congruent. So if we have an isosceles trapezoid, what do we know about it? We know if a trapezoid is isosceles, then the base angles are congruent. Okay, an easy way for me to remember that is if I draw that isosceles trapezoid over here, if these are my bases, I know the angles that are lying on the same base are going to be equal. So these two guys are equal, and then these two guys up here are equal because they're lying on the same parallel line. Okay, so my base angles are congruent. What else do we know? Whoops. Theorem 615. If a trapezoid is isosceles, then one pair of base angles are congruent. Oh, I wrote that wrong. If a trapezoid has one pair of congruent base angles, then it's isosceles. So if you're given that trapezoid, here's our parallel lines, okay? If you're given that trapezoid and I know that one pair of those base angles, these guys down here, are congruent, then I can go ahead and say, hey, that's isosceles. Okay, next one. A trapezoid is isosceles if and only if the diagonals are congruent. Okay, so again, if we have that trapezoid, here's my bases are parallel. If we draw in those diagonals, the diagonals will be congruent, which means AD is congruent to CB. Okay, so let's practice a little bit. I'm going to give you one picture and we're going to work off of that. Well, that didn't work. So here's my bases. I'm going to tell you this is L, M, N, O. This is going to be 3x. This is going to be 60, Z, Y, and x plus 13. We are going to name the legs, name the bases, and then we're going to solve for x, y, and z. So from that picture, I want you guys to go ahead and find the legs. Go ahead and do that now. Okay, so your legs, remember those are not the parallel sides. That would have been LN and MO. And this guy and this guy. Okay. What else do we know? Oh, I forgot to tell you. This is isosceles. Important information. All right, name the bases. The bases are the parallel lines. So we have LM and NO. Those have the parallel marks on them. Okay, those are the bases. Okay, if this is an isosceles trapezoid, what do we know about the legs? We know that the legs are congruent. So we're going to take these legs and we're going to set them equal. And then solve. So there's x. Now I want you to pause the video and solve for y. Okay, so solving for y, both of those angles lie on the same base. So what do we know about them? If they're on the same base, they are equal. So y would be 60. Okay, now think parallel lines with me. Okay, we've got parallel bases, and then this leg can act like a transversal. So these two guys, just like our other parallelograms, these two guys would be consecutive interior angles. So they add to 180. So 180, try that again, Z plus 60 equals 180. So Z is 120. Okay, so there's your example for a trapezoid. Now there's one more thing that we have to learn about a trapezoid, and that would be a mid-segment. So a mid-segment in a trapezoid. Okay, this is technically theorem 6.17 if you're naming them that way. Okay, so if I have a mid-segment in a trapezoid, the first thing that we want to do is draw it so we know what we're looking at. So here's my trapezoid. Now the mid-segment goes right through the middle. The mid-segment is parallel to the bases. Okay, I'm going to call this A, B, C, D, and M, N. So the mid-segment is going to cut each leg in half. But if this isn't an isosceles trapezoid, they're not all going to be congruent. So if it's going to cut each leg in half, that means BM and MA would be the same. And then CN and ND would be the same. Cuts each leg in half. Or it bisects each leg. We also can find our mid-segment with our mid-segment formula. The mid-segment equals 1/2 of base 1 plus base 2. Okay, so if we're going to apply that to this picture, my mid-segment is MN. That would equal 1/2 of base 1. So BC is a base plus the other base, which is AD. Okay, you need to know this formula for sure, so make sure you have it written down. Okay, a couple that we're going to do as examples. going to tell you that LM is a mid-segment. Here's LM. I'm going to tell you that this is 15, this is 2x, and this is 8. So what do we know the mid-segment does? The mid-segment cuts each leg in half. What's that look like? That means we have these two are equal, and we have these two are equal. So how are you going to solve for x? You're going to take the 2x and set it equal to 8 because these two are the equal pieces. So x equals 4. Okay, now let's do a couple where we solve for the mid-segment or use the mid-segment formula. So if this is my trapezoid, here's my mid-segment. Okay, so I know my mid-segment equals 1/2 base 1 plus base 2. Well, what's my mid-segment? My mid-segment's the unknown, that's x. My base 1 would be 15. My base 2 is 27. Now, does it matter which one base 1 and base 2 are? No, just make sure that they're the parallel lines. Now we're going to solve. Okay, so 15 plus 27 would be 42. Half of 42 would be 21. Okay. Last one is going to be a little bit different. This one, I'm going to have you solve for a base. Okay, so here's my mid-segment is 15, so I know that the mid-segment equals 1/2 of base 1 plus base 2. So what's it give me for my mid-segment? It gives me 15. What's it give me for one of the bases? X. What's it give me for the other base? 28. Go ahead and pause the video and solve for x. All right, to solve for x, we needed to get rid of the 1/2, so I'm going to multiply both sides by 2. And then I'm going to subtract that 28 over to get x equals 2. So that other base would be 2.